So the following is an introduction to using functions in Python. Functions are really quite ubiquitous and make up a big portion of what is done within Python and any other coding language. Some of the key uses for those are being able to reuse portions of code and also organizing the code into a manner that helps with understanding and the flow of the work. There's also many libraries, external libraries, that provide lots of useful functionality. The keywords for using functions are def, which is used to define a function, and the return statement. The following is a straightforward example. Def sum1 parentheses, and then we have x comma y end parentheses. So this would be a function of variables x and y. Again, we see the use of this colon to set off the function, and then the body of the function is indented. So they have the def keyword, then the name of the function, then in parentheses a comma separated list of function arguments. In this case, we set a new local variable called z, which is equal to x and y, and then the return statement is what returns a value from the function. We can call the function by mySum, for instance. mySum equals sum underscore 1, the name of the function, and then we pass values or variables into the function, and when we pass in 5, 6, x will take on the value of 5, y will take on the value of 6. We add those together, store it in a variable z, and then return that variable, which will be 11. That variable 11 gets assigned to the variable mySum, and then we can output that, and we see in fact that the value is 11. Here's another function. Return statements are optional, so if you don't want to return a value, you don't have to. The function can do work on its own without returning anything. In this case, we pass in x and y and sum the values and print them to the screen without returning anything explicitly. We can also return an expression. It doesn't have to be a variable. You can return an expression. So in this case, return x plus y, and that'll just return the sum, because the quantity x plus y evaluates to the number 11, and we can return that value. And in this case, the print statement is printing the call to the sum, and the sum is what this return statement is what this whole sum evaluates to. So again, we get an output of 11. If you have any statements after a return statement, they won't execute. So when we run this sum4 command, this final print statement is not output to the screen because it happens after a return statement, after the function has exited because of the return statement. Functions can return more than one value. In this case, we have a function called add and multiply, and if we pass in x and y, we can return two values, the sum of x and y and also the product of x and y, and these are separated by commas. And then when we call the function, we can assign it to two separate variables, add comma mult equals add and multiply 5 and 6. And when we print those two variables, we get out 11 and 30. So functions can return more than one value in Python. Functions can have default arguments. So in this case, we have a getForce function, which simply multiplies mass and gravity. But notice in this case, when we declare the function, we have g equals 9.81. So when we call this function, if we don't tell it what g is, if we just leave this parameter blank, it will assume it's 9.81, and otherwise it will use the value we ask for. So here we print getForce, and we've only passed in 10, so mass will have the value 10, m will be given the value 10, and because we don't specify another parameter for g, it's going to take on the value 9.81. If, however, we call the function here getForce 20, 2, in this case, m will take the value of 20, and g will take the value of 2, because we've specified the other value. You can also explicitly state the name if you like. You can type 20, g equals 4, and this will explicitly set g to the value of 4 when you call the function. So instead of it being 9.81, in this case it would be 4. So there's a couple of examples of using default arguments, which can be convenient in many cases. Documentation for functions can be done using a triple quoted string at the beginning of the function. We call it a doc string, and you can output the documentation for the function using help. So here's a function called squareIt, which simply returns the square of x. And this triple quoted string here, you can see Jupyter colors it red, is the documentation for the function. So we tell it what comes in, what gets returned, and some other useful or not useful information. And then return x times x. If we type help squareIt, help the name of the function, then what is output to the screen is this doc string. So we get the function, its arguments, and then the documentation that is listed in here. Functions can be passed as arguments to other functions. So you can pass both values and variables and even functions and other kinds of objects to functions. So here's an example called course integrate f. Suppose we want to integrate a function, but we want it to be any function. Maybe we want to integrate sine of x or integrate x squared or any other function. So in this case, we would want to pass the function as an argument, the function that we want to integrate as an argument. This function takes a lower bound, x low, and an upper bound, x high, and then the name of the function that we're going to integrate. In this case, it's called f in the function argument list. What this function does is it simply takes this range from x low to x high and turns it into two different rectangles, and then returns the sum of the areas of those two rectangles as an approximation for the integral of the function in those two regions. So to do that, I find the midpoint of the region, call it x mid. We find dx is just the width of each rectangle, so x mid minus x low, which is the same as x high minus x mid. And then we find the area of each rectangle is just delta x times the function f evaluated at the midpoint of each rectangle. And then we can just return a1 plus a2, the sum of the two areas. So then we can define two other functions. We can define f of x equals x squared, which is given here. And we can define some linear function given here. We could also define any other function we want with any name that we want. And then when we want to integrate it, we can define some bounds, x low and x high, and then call the function, course integrate f with our bounds, x low, x high. And here I'm calling it with f x squared, and here I'm calling it with f linear. So f x squared, when we pass that in, f represents fx squared. And when we call the function with f linear is what is used when f becomes an alias for f linear. So when we call f here, it's calling fx squared, or when we call f here, it's calling f linear, whatever we pass in as the function argument. And the results of this for x squared is 20.4375. The exact answer is 21. And for the linear function, we get the exact answer because it's a linear function. So it's just a quick example of using passing one function as an argument into another function. Function arguments can be specified out of order if we're explicit about the names. So if I have a function ab, I can call it with b first and then a if I tell it what the name is. B is 5 and a is 7, then it doesn't care what order it's in. And it looks like I forgot to add parentheses on my print statements here. A function needs to be defined before it is used. It's nice to define your main code at the top with subfunctions below that because it helps with the organization. But that doesn't always work if you have functions that you call at one point but you don't define them until later. Python doesn't know about those later functions. However, you can get around that if you call a driver function at the top that then calls subfunctions that are defined below, and then you call the top driver function at the bottom. That way your code can be read top to bottom so that it's easy to read, but it still executes since it's not called until everything has been defined. So here's an example of what I mean by that. So here I have a driver function, and it calls function f2, but I don't define f2 until later on. So at this top point, it doesn't know about f2 yet because f2 hasn't been defined in the right order. But this is okay because it doesn't matter where the functions are defined. It matters if they're defined at the point when it's called. So driver isn't called until the very end. It's defined at the beginning, but it's not called until the end. And so everything works fine. So you might have a really long, complicated function here called driver, and it calls lots of other functions that are defined below. And everything's fine as long as you call the driver function at the bottom. If instead I didn't have this in a function, I just had a bunch of code here that called f2 and other functions, that wouldn't work because those functions haven't been defined at the point where they're called. And that's why if we wrap it in a function, then it's fine because we're not calling the function till the bottom. There's some issue with global versus local scope. Variables that are defined inside of a function are only visible inside of the function. They're called local variables. Variables that are defined outside of a function and above the function are visible inside the function, and those are called global variables. So here's an example. If I define a up here at the top and then define a function called ff, then a print statement inside of that function can have access to a. Notice that I'm not passing a through the function, not through the argument list, but it's still available so that when I call the function, it outputs this variable a. In other words, a is seen inside the function because a is a global variable. However, if I have this function ff2 and I define abc inside the function, abc is 2.2, abc is only seen inside of the function. So if I try to go outside of the function and type abc, nothing happens because abc is only known about inside of the function. I can also define functions inside of functions. So here's a function called f_outside, and it takes an argument called x_out. And then inside this function is another function called f_inside, and it just prints x_in and x_out. So notice that x_out isn't passed in through this argument list here, but is still available inside this f_inside function, and because it's a global variable, because this f_inside is declared inside of the outer function. So when we call f_inside f_outside with the variable 1, x_out becomes 1, and we get and then inside this function we call, or f_outside we call it with 2. So x_in is going to be 2 and x_out is going to be 1. And in fact, that's what we see. x_in and x_out become 2 and 1. However, if we then call f_inside from the global scope, it doesn't work because the inside function was inside of this outer function, so it's local to this. Function f_outside, and you can't call it outside the function. Tuples are special variables that we need to describe one more aspect of Python functions. Tuples are just special variables that are really just a list of values. We can define them as a comma-separated list in parentheses, and we can access elements with brackets starting at 0. They can have mixed types, but once they're set, you can't change the elements of them. If you want to change the elements, you need a list. So here's an example. A is equal to parentheses 1.1 comma dog comma 11 comma f_outside. So this is just a comma separated list of different objects. Here's the object 1.1, here's the string object dog, here's an integer object 11, and here's a function f_outside. We access those values by using bracket notation where we start at 0. So a bracket 0 will access the first element, which is 0. The second element is 1, 2, 3. And we can print those out as a list. And what comes out is, because I've reversed the order here, A3 is the function, and it tells me it's a function object. Then I get A2, which is 11, 0, 1, 2. 2 is 11. And then I get dog, which is A1. 0, 1 is dog. And then A0 is the first element, which is 1.1. So this is an example in the first line of just printing the elements in a comma-separated list. And if we print the whole tuple, then it outputs the tuple between parentheses. And that's an easy way to tell that it's a tuple, because it's a comma-separated list of objects between parentheses. In the example we had before, where we had the add and multiply function, which returns both the sum of these variables and their products as 2 return values, what's really returned is a tuple. So if we assign b to that and then print b, we get the tuple 11 and 30. If we print b0 and b1, we get the values 11 and 30. And in the example that we saw before, we had done like the sum, comma, the product equals this, so it assigned each element to those variables. But you can also assign them directly to a tuple. You can have a 0-size tuple with just 2 empty parentheses. If you want a tuple that just has one element, you need to put a comma in it so that it doesn't just think it's 1 between parentheses. So 1 comma, the comma indicates this is a tuple and it only has one element. You're not allowed to change values. So in the tuple b, if I try to assign b1 equals 5.5, I get an error because tuples can't support item assignment, as noted. The len function, len for length, will tell me how many elements there are in the tuple a. So a up here had 4 elements, and I get, when I type len a, it outputs the value 4. Functions can have an unspecified number of arguments. So given the function, an argument called star arg is the way that you would do this. You need the star, but you can name the arg anything you want. You could call it my variable. This allows you to specify an unnamed number of arguments, and it's handy if you don't know how many arguments should be passed. So suppose you want a function that just combines all the arguments that you give it, or a function that adds all the arguments given, but you don't know how many you want to add until you call the function. So here's an example. Some function, I have a normal argument 1, I have normal argument 2, and then this star args is the special one, and that's going to be shorthand for any other arguments I give it. So in this case, the function just prints the first argument, prints the second argument, and then it asks if args has at least one element. Then I'm going to print the first element of args. So args is just a tuple, and the star args is the notation when you define the function, but when you use it, you just call args. So len args, if the length of the args is greater than 1, then I output the first argument, and if it's greater than 2, I output the second argument. So when I call this function, I have some func my, comma, name. So my will go into normal arg1, name will go into normal arg2, and then all the rest, these ones will become elements of a tuple called args. So in this case, my name is Jerry. I get that output where args0 is, and args1 becomes Jerry. So pretty straightforward to use it, and just a notation for allowing it any number of arguments. There's other nice features of functions. You can see online anonymous functions, or sometimes called lambdas, and also another analog of the args called kwargs for keyword-based arguments, and you can read more about those online.